Hello guys, welcome to day 2 of learning IoT with the last minute prep. My name is Uday and today we'll go deeper into the world of IoT or the Internet of Things. We'll explore how the IoT devices are built internally and what protocols they use and how they communicate, and I will ensure all technical terms are explained clearly so you can follow along easily. Okay, let's start with the slide. Okay. So this diagram represents the key components inside an IoT device. So let's explore each section and its role in detail. So let's start with connectivity. So connectivity ensures the device can communicate with the internet or the other devices such as a keyboard, the mouse that we are using, etc. So this USB host, USB stands for Universal Serial Bus. So allows the IoT devices to connect the external peripheral, so like the keyboards and the mouse, the cameras and the storage devices like external hard disks, etc. And coming to this RJ45 or Ethernet cable, so it refers to a wide connection for stable and fast internet communication. We used to see this type of Ethernet cables in our labs in our colleges. So it is common in industrial systems where reliability is the key. And next we have here is processor. So the CPU, also called as central processing unit, is the brain of the device. It handles all the calculations, it executes programs, and it processes the data. For example, in a smart air conditioner, the CPU processes temperatures data from sensors like in the real world, like in our projects we used to use the sensors like DHT to measure the temperature, atmospheric temperature, and decide when to turn the cooling system on or off. So this is what what a CPU does. It is the main component for the whole IoT device. It is like the brain. It controls the output based on the input that was taken by the sensors. Okay, and coming to audio and video interfaces, in this audio and video interfaces we have HDMI and 3.5 mm audio and RCA video. So what is HDMI? So we all know about HDMI. So HDMI refers to a high definition multimedia interface. It is used to send high resolution quality audio and video signals to displays like smart TVs in our homes or the projectors that we use in our colleges, etc. And coming to 3.5 mm audio jack. So uh, it provides audio output for headphones or speakers in IoT devices like smart speakers and this microphone that I'm using right now. And coming to RCA, so RCA stands for Radio Corporation of America, a legacy interface used for analog video output, often found in older home security systems. Like we used to have these type of cables in our during our childhood. Like we have three cables. One is red color, one is for like white color, and one is yellow color. So each cable use it for one type of signal, like one is for video, one is for audio, etc. Okay, and coming to input output interface for sensors and actuators. So these interfaces connect these IoT devices to external sensors, actuators, or peripherals. So UART, universal asynchronous receiver and transmitter, it is commonly used for serial communication between devices like the GPS modules and the microcontrollers. And coming to SPI, the serial peripheral interface, so it facilitates fast communication between the devices and the multiple sensors. For example, SPI is used in weather monitoring systems to connect sensors like temperature and the pressure also. Okay, and this I2C is used for communication over short distances such as between microcontrollers and sensors in the smart devices. And coming to CAN, so controller area network, it is a robust communication standard often used in the vehicles and the industrial automation to exchange data between the components like engine and control units and braking systems. Okay, and coming to the memory unit, we have this NAND or NOR gates and DDR1, 2 and 3. So what the memory unit refers is it stores the device's programs and data. So the NAND or non nor flash memory gates, so use it for long-term storage of firmware and important data. So your smart thermostat, for example, stores its operating system there. Okay, and coming to DDR, so what DDR refers to, it refers to double data rate. It's a RAM, DDR RAM. Okay, it provides temporary storage for real-time data processing, like DDR1, DDR2 and DDR3 refer to different generations of RAM while increasing speeds and efficiency. So it is also known as the volatile memory. And coming to the graphics, so the GPU, the graphics processing unit, so it processes the graphical data such as rendering images and videos on smart displays. For instance, in IoT enabled dashboards, the GPU handles visual elements like the pie charts, etc. These are the examples for this GPU. And some storage interfaces like HD, MMC and HDIO. So HD is a secure digital card. We all use this in our mobiles. And MMC, multimedia card, and HDIO, secure digital input output. So this SD is used in IoT cameras or drones to store video recordings or images. And this MMC, an older but a similar storage technology used in embedded devices. And coming to this HDIO, so it extends the HD card interface for adding additional functionalities like the Wi-Fi or the Bluetooth in IoT devices. So together these all components work seamlessly to collect, process, store and share data in IoT systems. So this is all the physical design of the IoT. Okay, and next we are going to talk about the protocols, the IoT protocols. Okay, so what is a protocol? A protocol is essentially a set of rules that defines how two devices communicate. Like think of it is a common language that both devices understand. Without protocols, devices wouldn't know how they talk to each other. Let me explain this with a simple example. So imagine you are writing a letter to a friend in the other country. So you both agree to write in English so that your friend can read it. In this case, English is the protocol ensuring the message is understood. Okay, I hope you understand what a protocol is. So these protocol define two things. One is how is data transmitted and how is data interpreted. Okay, um, so for example, how fast the data is sent and what it sends. So I'm sorry, so and in what format. Okay, so for example, how fast the data is sent and in what format. It is referred to how data is transmitted. And how data is interpreted means it ensures the receiving device understands what the data means. Okay, and in IoT we use protocols like this MQTT, message queuing telemetry transport, this CoAP, the AMQP, and there are 4 layers of protocols in IoT. Okay, for now I'll tell about this application layer, transport layer, what are these layers, and I'll give a brief description about these protocols, and we'll get into deeper about these protocols in the upcoming lectures. Okay, so let's go with this application layer. Okay, so the application layer handles the data that end users and applications interact with. Like it ensures the information is formatted, organized and ready for use. So common protocols here in this application layer is HTTP, the hypertext transfer protocol. It is used for transferring data between the web servers and the clients. So for example, a smart thermostat might use HTTP to send temperature data to these to the mobile apps that we are using right now. And coming to the so MQTT refers to message queuing telemetry transport protocol. So it's a lightweight protocol for messaging, like ideal for low power devices like sensors in a smart home. So it uses a publish subscribe model, ensuring efficient data transfer. We'll look into it, what this publish subscribe model and what are the IoT models in uh, next sessions. So, and coming to this CoAP, the constraint application protocol. So this protocol designed for constrained devices with limited power and resources, like IoT devices running on batteries. Okay, and the AMQP, advanced message queuing protocol. So this protocol for messaging oriented middleware. Okay, it's commonly used in systems where reliable communication between server is crucial, such as financial. Okay, and coming to this transport layer. Okay, this transport layer ensures that data is delivered reliably and in the correct order. So it deals with the how devices establish and maintain connections between two major protocols. So here the protocols in this TCP, like in the transport layer, one is TCP and second one is UDP. So TCP is considered as a transmission control protocol and UDP is a user data protocol, datagram protocol. Okay, this TCP here, this TCP provides reliable, ordered and error check delivery of data. For example, let us say IoT devices, like video often use IoT devices like streaming live video. Okay, often use TCP to ensure a smooth playback. So UDP. Okay, so UDP is a faster and reliable protocol. It used in applications where speed is more important. So compared to this TCP, the UDP is faster. But UDP is but TCP is connection oriented protocol where UDP is not. Okay, and coming to network. See, this network layer is responsible for routing data between devices. So this layer ensures that data packets reaching the destination protocols here includes the RPL, CORPL, CARP and LAN, etc. Okay, so what this routing protocol for low and lossy networks like use RPL. Okay, so it is specially designed for IoT networks with limited resources like smart city sensors, etc. We will discuss about this network layer in detail. Okay, coming to the physical and data link layers with the actual transmission and uh, actual transmission of data over various media such as radio frequencies, wires or optical cables. So key technologies include this Bluetooth, Zigbee, Wi-Fi. So Bluetooth, a short-range wireless communication protocol commonly used in wearable devices and smart home appliances. And Zigbee, it's a low power, low data rate protocol widely used in industrial IoT and smart lighting systems. And coming to Wi-Fi, so wireless fidelity provides high-speed wireless connectivity commonly used in IoT applications like in smart TVs and security cameras. So this is what about the protocols, IoT protocols. Okay, so we'll discuss about these protocols: HTTP, MQTT and this TCP, UDP. What are the handshake, what is the handshake, TCP handshake, and how the data is secured during the data transmission. Okay, we'll discuss about this in upcoming lectures, and let's go with the logic design of IoT. Okay, this is the logical design of the IoT devices. So let me break down each component in a way that easily understand. So first one is the application layer. So what is the purpose of this application layer is it handles all the user facing aspects of an IoT system. So it's where and users interact with IoT devices or applications, so such as through a smartphone or the web interface. Let me give you a simple example for that. So assume that we are using a weather app receiving real-time data from sensors, or a smart home app controlling lights, or thermostats, or security systems. So the app that we are using is an end user interface, so it is the application layer. Okay, and coming to this management layer, so what is the purpose of this management layer is it is responsible for overseeing the entire IoT system, like managing devices, users, and the network. For example, the network management tools that monitor device performance, this battery levels, and the data usage, and ensure the devices are operating correctly. Okay, and coming to this service, so it offers various functionalities that support the operation of the IoT devices and applications, such as the data storage, data analytics, and remote device control, etc. For example, the cloud-based services for storing data generated by IoT devices, or using and make decisions. Okay, that's what the services can do. And coming to the communication, so the purpose of this communication layer is it is responsible for the data transmission between the IoT devices and the networks. So it ensures that data is sent and received across different networks, like the Wi-Fi, Bluetooth, or the cellular networks. Okay, for example, data from a fitness tracker being sent to the smartphone via Bluetooth, or a smart thermostat sending data to the cloud via Wi-Fi. So how this communication is going to happen? This communication layer uh, will take the responsible for all this communication between the devices. Okay, and the next thing is security. So this layer ensures that the IoT system is protected against various security threats. It involves protecting the data that is being transmitted between these two devices, like the end users, and the communication channels through which data flows. Okay, it provides security for the data, so no person, like no third party person, can uh, have the access for the data. Okay, and lastly we have this the device layer. So what this device layer consists of, so it consists of all the physical IoT devices that collect data from the environment or these specific tasks. Let us say sensors like temperature and humidity sensors, the actuators, um, the smart appliances like fridges, lights in our homes, and the wearable smartwatches. Okay, these are all comes under this device layer. So the logical design of the IoT integrates these layers to create an efficient and secure ecosystems where IoT devices communicate, okay, and managed and provide meaningful services. By separating the system into distinct layers like application, like this application management services, communication, security, device. So IoT systems can be easily scaled, monitored, and maintained. So each layer plays a crucial role in ensuring the IoT system functions effectively, securely, and it offers value to users and the business alike. Okay, and IoT communication models. So now let's look at the four type, four ways of IoT devices, like how they communicate. We have these four types of communication models. One is a request response model, publish subscribe model, push pull model, and this exclusive pair model. Okay, let us look into this in detail. The first thing is request response communication model. So this is like a conversation, like one device asks for the data and another response. Okay, for example, when you ask your smartphone assistant for the weather, let us consider this, sorry, okay, let us consider this is your mobile, this is your mobile, and this is the server, and this is the resources of the server. So what your mobile will do is it sends a request to the server. So this is the request, it sends a request to the server. So what server did, after receive the request from clients, it processes the request. So it look up, fetches resources, like these resources, and it sends the response to the clients. Okay, then your mobile will show you the what is the weather. It is just like a conversation between the sensor and sorry, I'm sorry, it is just like the conversation between the client and the server. And coming to this publish subscribe model, so one device, this is the publisher, so it sends data to the broker. So this is called broker, and other devices, these are called subscriber 1 and the subscriber 2. Okay, so what is happening here is let us consider our other station publishes its updates. So let us take the station, this is the station, it is the publisher. So and your phone receives them because when it publishes about the weather, your phone, let us say this person, this subscriber subscribed for this topic about the weather. Okay, and let's say this topic B, this is about the rain and this is about the temperature. Let us say this subscriber only subscribe for this topic, and this subscriber, let us say here there is one subscriber here, and this subscriber for this topic, this is about the rain, topic 1 is rain, and topic B is, and this topic B is the sun. Okay, so when the station published the data about the topic rain, so it is topic A, so the persons who subscribed for this, like the device who was subscribed for this topic, will receive the notification about this update. When about the sun, these subscribers will receive about the sun. Okay, in real time we'll say YouTube is the best example for that. Okay, for example, a fitness tracker might push data about steps to a cloud service. Assume this is a cloud service, and um, this is a device that pushes about your steps and about your heart rate in the day all into this. So when a consumer wants what is the highest heart rate of the day, so he can access that data only, he can pull that data only. This is known as the push pull model. And coming to the last, which is also called as the exclusive pair communication model. So this exclusive pair communication model is a specified interaction between two devices, where one device acts as a requester and other as a responder. So this is a type of communication is typically 1-to-1. Okay, ensuring the both devices are involved in the communication process at the same time. Like when client want to communicate with the server, it sends a request to set up connection. When the server responds for accepting the connection, this is the part where the data is being transmitted and received. So okay, and after the data communication over, so the client will send the connection closed request to the server, and the connection between the client and the server is closed. So this is about the exclusive pair communication model. Okay, this is about today's lecture, and we'll see about the protocols like MQTT, HTTP in detail in the future lectures. So please stay tuned for the updates for last minute prep, and thank you.